up, YouTube? All right, so I'm at a point where I've realized that I fucked up. When I reran the heater lines off the water pump to clear the upper control arm, when I routed the return line, I put it into the bottom of the water pump in the same channel that the return water from the heater core flows through as it would come from that port. But I'm north of the thermostat. Now those heater ports, the heater return port specifically enters the water pump directly next to the thermostat itself. So the return water, if you imagine, is blowing right across the thermostat spring. So it's immediately raising the thermostat temperature up to the same temp as the engine minus whatever heat is bled off by the heater core, which is a nominal amount. Um, the problem I have now is that I've rerouted that return away from the thermostat. So the heater return water, that hot water coming out of the engine, is going straight back into the pump. It's not warming the thermostat up. Now, it's only a couple inches from it, so I'm sure there's still some residual temperature change in the thermostat because of swirl in that pocket. But that thermostat spring is essentially just sitting in a cavity right now with no flow through it other than what's bleeding through the air bleed or any bleeder holes in the thermostat itself. So, you've got this, let's say you start the car up at, it's 70 degrees out. You got 70-degree water coming in from the radiator through the lower hose, whatever minute amount is bleeding through around the thermostat. And you've got a little bit of swirling hot water 6 inches away from it in the water pump. And how much of that hot water is mixing with the cold water coming through the thermostat from the radiator side is not much. And you've got a radiator's full supply of cold water coming through whatever's being sucked through the bleed in the thermostat surround until the thermostat opens to dilute the temperature down and keep that thermostat cold and closed. So the thermostat is not opening. I'm not getting enough flow. I mean, it may open to some degree, but I'm not getting anywhere near full flow. The engine is getting hotter and hotter, and eventually it'll warm the radiator up enough that it's hot enough, but you'd have to be baking this motor away for an hour at 240 degrees to get that radiator hot enough because there's so little flow through the radiator. So, I mean, I can open a second bleed, drill an 1/8 inch hole or a 3/16 hole in the surround of the thermostat to let a little more water bypass, but still you'd have to pump out that whole radiator full of 70-degree fluid before the hotter engine temperature water gets around. And we all know how fast these LSs warm up in the morning. It's largely because of that thermostat block off. And then I found some other stuff out too that I had kind of, I had maybe assumed incorrectly or just hadn't had that much exposure to the way these cooling systems, LS cooling systems, are engineered. I kind of misunderstood some stuff. Like the second plate in the back of the thermostat is actually to plug off the bypass. So if the heater core were to get clogged, or the hose collapsed or crushed or something like that, with the thermostat closed, and the heater hose, the outlet to the heater is always fed water out of the water pump. So if the heater got blocked off or turned off or disconnected, then you would essentially end up with, you'd be deadheading the pump. That would have no outlet until the thermostat eventually opened enough to allow water to pass through the thermostat. You'd have a tiny little bleed, a tiny little bleed amount of water circulating, but that's not nearly enough. I mean, you'd end up just wearing out the pump vanes or breaking the pump, whatever. So that's what that's what that flat is on the back of the thermostat. It's funny. I've been dealing with those things for 20 years, and I never knew that much about the engineering of the water pump and the cooling system to really get that into it. Typically it's not something you address as a tech. Thermostat goes bad, you change the thermostat. But what that little plate does in the back is that's not a that little plate in the back is actually a bypass for the heater hose. So that little plate is on a lighter duty spring, and as the outlet pressure to the heater core goes up, it'll actually unseat that plate from the inside of the water pump and allow water to pass and circulate back into the inlet side of the pump to keep water circulating so you're not deadheading it. So that plate doesn't move with temperature. It doesn't open when the thermostat opens. I guess I just never understood that, so I do now. So yeah, I'm going to throw up a couple of pictures as I'm showing, so hopefully this stuff will come through on editing, on post. But so what I'm going to have to do is, obviously I can drill a bypass on a thermostat and allow some more water to bypass the thermostat so I can cycle the I can cycle the radiator water through faster to warm the radiator up, but that's going to take forever. I'm not happy with that. So what I'm going to do is relocate the return from the heater core from the spot where it currently is on the bottom of the water pump to right next to back in the thermostat housing, but right on top. So I still have to clear the control arm, but I have room around the thermostat housing to get that pipe plumbed in. I'm a little leery because the housing is an unknown thickness right there, and I don't know how many threads I'm going to be able to get in an MPT tap, and I've got to be careful not to over drill it, because if I sink my MPT elbow too far into the housing, obviously I don't want to interfere with the thermostat function or run into the thermostat. So it's going to be a little delicate, but I'm going to have to drain the cooling system out, pull the thermostat out, plug that up so I don't get shavings up and through the system, and drill it, and have to be careful when I'm doing it. So I think what's going to happen is what I'm hoping will happen is that now when that heater core water is returning back to the water pump, it's not just going to go back into the pump and get pumped through the block again. It's actually going to flood across the thermostat spring, bringing the thermostat up to temperature much faster. And of course, once it opens, it's going to let cold water in from the radiator, but now it's going to stay markedly hotter, and it should open the thermostat eventually and much faster. It'll bring the radiator up to temp faster, to the point where you start to get good consistent cooling flow. Because what I'm having is, it'll run. I mean, it runs good, it warms up fine, and it doesn't overheat straight out of the gate. If I'm blowing down the road, I can still get a good deal of cooling, but I've also got a ton more RPM, so I'm pushing a lot more water past that bypass, and on the heater core. And then, of course, you have all the airflow around the engine itself and the exhaust and all that stuff from moving. So I don't really think it's radiator flow that's making it cool down once I'm moving. Certainly, if I'm sitting stuck in traffic, like I was the other day, I was doing a tuning log run, and I was stuck in traffic, and I almost baked it. It was like 240 degrees. And, these LSs can take a lot more temp than the old school small block, so that's not, I'm not happy about it, but I'm not terribly scared about it. And of course, I pulled some plugs and checked it out. I don't think I had any compromise. It's a fresh motor. It's in good shape. Brand new head gaskets, and the head's been, the heads are flat, the block's flat, and so I don't think I'd hurt it. It's 240 degrees on an LS isn't a happy place, but it's not an awful place. You do that on an old small block, and you're nuking head gaskets and potentially cracking a head and all kinds of stuff. So I'm gonna get going. I'm gonna get the system bled out, and I'm just gonna disconnect the thermostat cover and the thermostat water neck, and drop that off and let it drain out, and I'll pull the AC compressor back off, and I should be able to see if I can show you what I'm talking about. There is the back, and you can see the end of the water neck right there. So I'm going to tap that flat right down there. Focus, come on, bastard. So I'm going to tap that right there and mount my elbow there. Right now, it's currently, let me see if I can get this camera down here. Watch what I'm doing. There's my return right there, plumbed into the bottom of the water pump. And as you can see, it's a few inches away from the thermostat. So I think that water's coming back into the water pump in return section right there and going right up into the pump. There's no reason for it to back up other than turbulence and flow to get back to the thermostat. And it's going to have to offset the water coming in through the thermostat that's cold. So really, that thermostat spring is going to take forever to open up, and I think that's what I'm up against right now. So I'm going to get this guy drained out and pull the compressor and start moving that over. And I'm also going to change up the cooling system. Has been, these are notoriously hard to bleed because the cylinder heads are so high, especially in this car because the radiator is so low. So I'm going to mount a filler neck in the top hose that's elevated so I can use that as a bleed. And I'm going to use I picked up a Moroso like 32 psi cap for the radiator. So I'll cap that off and block the return, or block the bleeder line out of it, the steam bleed, so it never vents there, and it'll vent out of the cap I'm going to put in the top hose. And I got a new cap for that. And I can route that back and use the same bottle. I'm not going to use a pressure vessel like the LSs do. This should work just fine. Worst comes to worst, I can replace that hose, and I do have the heater core supply hose right here is in a perfect location to tee into it, and then run a pressure bottle instead of running the overflow, or All right, so here we are. But I'm going to get rolling. I rerouted that return line from the heater core right on top of the thermostat housing. so that it dumps right on that thermostat spring. And I use some heat shielding on there because it's getting a little close to the exhaust manifold. I'm going to get a tie-off clamp also to tuck this over up against the firewall, get it a little more airspace between the manifold. And there's a new the new vent line coming off the new radiator cap junction on top of the upper hose. It gave me a chance to kind of relocate that hose and straighten it out a little more. And then while I was there, because I might as well as just kick in hardcore with me, I redid the steam line up front with a new aftermarket billet aluminum block and some AN lines to the back of the water pump. I'm not overly happy with it. I mean, it works. It purges air out. I'm still getting a little bit of air buildup in the back of the heads because the motor, as it sits in this car, sits fairly level. On the trucks, the motor sat back more, on more of an angle, so they plugged off the back ports, and you can see the, let me find a clear one. You see that port back there behind the oil pressure sender is just a block off, just a bolt and a block. Seals off those rear steam ports. On the truck, you don't need it because the rear of the heads sit so much lower than the front, so the air normally works its way to the front anyway. But this takes a little bit of doing, so I think next time I drain the cooling system out, I'm going to pop those ports off the back and I'm going to run a connecting line so I can auto vent the back of the heads. I mean, the air's out now and it's cooling much better. I think that's it. I think that was the core of it. And I think we're good to go. So that was it. So there's my feed line coming out of the pump to the heater core. And that comes out of the outlet side of the pump and it runs over, goes to the heater core, and then when it comes back from the core, it now goes directly on top of the thermostat housing. There's the fitting going in down there. And that blows right on the thermostat spring and helps the thermostat come up to temp and stay open so it can actually cool. And that's all, folks.